right, section 11.1, sequences. Normally, for a sequence, we just can see what they look like. For example, the even sequence, 2, 4, 6, 8. And now, just because we listed a few doesn't we know what we mean it will do forever. There could be some oddities. But a formula is really nice. But again, that's a sequence, so we should just say counting numbers or whatever, some sequence that we understand. Now we have several ways of writing this. One, we can use brackets and put the formula in there, and then we can say where it starts and where it goes to. Or I can give you a function, and then I can say a sub n equals f of n, and again I can tell you for what values of n. Something like that. These are all processes of creating sequences. Now the visualization of sequences is really interesting. If we just take the real line here, let me visualize a sequence for you. I'm going to give you the sequence of 1 plus minus 1 to the n over n equals 2 forever. So let's plug in 2. Minus 1 squared is 1. 1/2. We get 3 halves. There's a 2. Now, there is no a1 and a0 because I didn't make them. Now I'm going to put in 3. Minus 1 cubed is negative 1/3. 1 minus 1/3 will be 2/3. So here's a3. Now when I put in 4, minus 1 to the 4th is plus 1. I get 1 plus a 4th. And so here's a4. Now what's really interesting is it bounces back and forth. There's the ones that are over here. They're all that's a5, a7, and then the even ones, they're over here. Here's a6, a8, and what's happening is it's bouncing back and forth, but they're getting closer and closer and closer. It seems really clear that we can write the limit as n goes to infinity of an. Looks like 1. It's creeping towards 1 on both sides. So this is one way of visualizing a limit. Let's do a second way of visualizing a limit. The idea that a sub n is defined as n's placed into a function, well, let's take and draw a function that you've seen before, like f of x equals x over x plus 1. Now at minus 1, that is a vertical asymptote. Turns out the limit as x goes to infinity is 1. Looks like this. At 0 it goes to 0, and so here's this function. That's from Calc 1, but now I'm going to plug in numbers into here for n bigger than or equal to 1. So 1 over 2 is 1/2. So that's this point, and this is one way to visualize a1. Then plug in 2. 2 over 2/3. There's a 3, and 3/4. And here's 4/5. And so now these dots are viewed along here. But now the limit as n goes to infinity of an, it's where it's rising to. It's getting stable. Now both of those pictures have something in common. This picture has the idea that if I put any little small interval around here, if I take 1 plus an epsilon and 1 minus an epsilon, there's only going to be a finite number of these guys outside of that. This contains all but a few, a finite number of the ANs. That's what it means to have a limit. Same thing here, except the interval is a little different. It's here. There's an interval where all but a finite number of the heights of the function land in there, and some are outside. So let me give you a function that is misbehaved. Ready? I'm not going to put it on the xy plane. I'll just put it on the real line. So I'm going to tell you how this function goes. It's going to go 0, 1. Then it's going to come back to a half. then it's going to go to 1, then it's going to go a third and a fourth and go to 1, then it's go a fourth and a fifth and a sixth. So it's going to start at 0, jump to 1, 1 half, jump to 1, 1/3, 1/4, jump to 1, 1/5, 1/6, 1/7, jump to 1, 1/8, 1/9, 1/10, 1/11. So you can see half, 2 of them, 3 of them, 4 of them, but it always puts a 1 in between. Now what's weird is it seems to be heading back towards 0, which it was at, but it keeps on going back to 1. Now I could write down a function that does this, but if this 1 keeps on reoccurring, no matter how many of these dots get close to 0, if I put an in over around here, there'll be an infinite number of 1s outside. It keeps jumping out. This is a bad sequence. So when sequences misbehave, so when sequences have the limit of a sub n, n goes to infinity, of a sub n isn't a number, we say diverges, that the sequence diverges. It doesn't go anywhere. But when the limit, as n goes to infinity, of a sub n gets a specific value, we say a sub n converges, and we say where? To L. Now, some sequences are really important, and the reason they're important is that we have functions that don't have finite formulas. The formulas are infinitely hard, and we know these: the square root of x, e to the x, ln x, sine x. We know their names, we know how they behave, but you know what? We don't know how to calculate very many of their values. Now, there's some famous functions out there and sequences that people have been involved with. You may have seen 1 plus 1 over n to the n goes to e from Calc 1. You may have seen these kinds of sequences. F of n plus 1 equals f of n plus f of n minus 1, the famous Fibonacci one. It starts with 0, 1, and so if this is No, I'm in the middle of my second video. Why?
Listening?
What?
So they're listening?
No.
Download portion. Sorry, please. I was listening to you the other day. Were you talking about everything? Yabba, 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 yabba.
Wait, is that Hannah?
It is, wait, Dad wants you.
Are we going to return to your taxes today, or are you done? Hey, he's pouting at me. That's called jowls, kid. Show me your teeth. So anyway, you're almost done. You're going to get $1,000 back, and then you'll get your money. Did you get money in your checking account, you know? They're doing least earners first. First batch was processed for people who less than 60,000. They're going to low income. So do you know anybody who got them? Yeah, look.
Hi, Hannah. Did you leave her sitting there?
Yeah.
Oh, it's time for that. Yeah, dinner. Oh, wow. Zoom has a kind of unfortunate icon. Zoom's icon is exactly like FaceTime except blue. Or is it just green or whatever?